Alrighty, so we're going to continue with finding zeros of polynomials. Yesterday we talked about listing all the possible rational roots or zeros. Today we're actually going to not only list them, but use that list to kind of narrow down our search. Now look, realistically you have a calculator. A lot of times you can just graph it and you can see all the zeros there are. But there are times when we have imaginary answers and you won't be able to see those. So it's important that you know how to do this process, okay? So first, right here, your main steps, okay? We're going to follow those steps as we look at this first example, okay? Number one, how many roots at most does this polynomial have? 4. So we're looking for possibly 4, right? The rational zeros come from the p's and q's, so let's go through that process. P's are all the factors of what number? Okay, so those are going to be plus or minus 1, 2, 3, 4, 6. Good. And lucky for us, the Q comes from this 1 coefficient. That's just 1. So you know those annoying problems we did yesterday? When we divide here, we're not going to get any new fractions or anything. We're just literally going to have the p values, right? Because we're just dividing them by 1. So the possible roots, possible rational roots, are all the p over q's, but that's just going to be the same, you know, plus or minus 1, 2, 3, 4, 6, and 12. Okay, so that's step 1. Now what we're going to do, because if we didn't have a calculator, we would literally just start testing. Does 1 work? Do we get a 0 remainder with 1? Yay! Or, oh no, now I got to try another one because that didn't work, and that could take a long time. The calculator will help us get started though. So if we look at graphing it, let's just type that into the y equals menu. So x to the 4 plus 2x cubed minus 7x squared minus 20x minus 12. Okay. And a good place to start is always the standard window, so I'm just going to do zoom 6 and see what happens. Okay, so looks like maybe there's a 0 there or a 0 there. There's a clear 0 right here, right? Maybe let's find this one. What does it look like? And that's certainly on our list as a possibility, right? So let's just confirm it. If we do the zeros on the calculator, make sure you're to the left. I mean, and here's a good time to talk about this. I don't know if we've done this a lot. We're thinking the 0 is 3, right? So when it says left bound, instead of arrowing over, you could literally type in a number that's to the left of 3. Does that make sense? Mm-hmm. So if you typed in 2 and hit enter, your little arrow pops up automatically. Does that make sense? And now you type in any number to the right of 3, like 4, and then the little arrow on the right pops up, and now when you hit enter a third time, there it is. Does that make sense? So what does this show us? That 3 is a solution, or a 0 to the equation, right? Now, how is that going to help us? Well, let's see. Now we're going to have to do synthetic division. Okay? So write down the coefficients, 1, 2, negative 7, negative 20, negative 12. We're not missing any, so we don't have to have any zeros in there. What's going to happen when I divide here? There's going to be a remainder of 0. If not, we really screwed something up, right? Because the calculator just told us that it's a 0. So if I bring down the 1 and multiply, and then add, multiply, add, multiply, what is that going to be? 4. 4 times 3 is 12. There it is. So 0 remainder is good, okay? And now here's what we're going to do. This polynomial right here, is now a cubic. Does that make sense? We started with a degree 4, we divided it by x minus 3, and now we have a cubic polynomial left over. Okay? So now what we're going to do is do synthetic division one more time. But let's look back at this picture. Looks like there's another 0 over here, potentially at where? -1, which is, again, on our list, so that might be an option. Let's do the confirmation here. So we do 0. This one you can arrow over, and it's not too bad. So get to the left of that intercept, to the right of it, and sure enough, -1 is a 0. Does that make sense? So now we're going to divide one more time using this other -1 root. And now what does that do? Well, just throwing pens everywhere. Bring down the 1, multiply, you get -1, add, you get 4. Multiply there, add, you get 4. 4 times -1 is -4. Sure enough, we got 0, which we knew was going to happen, right? But more importantly, what degree is this now? It started as a cubic, now it's quadratic. Does that make sense? We started with degree 4, we found one root, divided it, got it to a cubic, used another root from a calculator, divided it, now we got a quadratic. What does this translate to? X squared plus 4x plus 4. And then we just set that equal to 0 now. And so look, I mean, yes, I think we can see on the calculator, I think that -2 is the other 0, right? But here's the important thing, you guys. This polynomial that's left over may or may not factor nicely. It may end up being that we have imaginary solutions. We have to use a quadratic formula maybe, right? So that's why it's important that we get down to this step. But for now, if you factor it, how does it factor? X plus 2 times x plus 2, right? So then the other root is -2, which, by the way, has a multiplicity of 2. So all the roots, all the zeros. We have 3, -1, and now we just found the last one, -2. Okay? Any questions on that? Yes?
Wait, well, after, like, the top step, like this,
Here?
yeah, there.
Uh-huh.
The other 0.
This one?
Yeah. How did you get -1? I got -1.999. Or did I do it wrong?
On the calculator?
Yeah.
Did it say -0.9999?
No, it said -1.999.
That doesn't make sense. Oh, you know what? I think you found -2. Yeah, you probably found that one. Which, you know what? Let's say you did that, okay? You would then, in here, for you, you would have put in a -2 as opposed to a -1. Well, you need to know 1.9999 on the calculator, it's 2. If you ever see it, or if it was like 1.0000, it's 1. And then you can test it and make sure you get a 0 remainder. Does that make sense?
Okay.
So,
Can you show me like one more time how to do this? How the other 0?
the one that I got?
Yeah.
Sure. So second calc 0. I'm looking at this one that's right here.
Oh, okay. I was looking at
You were looking at the other
yeah,
one. That's the only difference.
Okay.
But you know what? If you did it that way, you still would have gotten the same final answers. Your little polynomial, the quadratic that's left over, would have been a little different,
Yeah.
but you still would be able to factor it easily, and then you still would have gotten the same roots. Yes?
So I'm still kind of off how to get square root of 2. So like when you get 1, 4, and 4 as a result of the 3,
Yes.
how does that go towards?
To this?
Yeah.
So let's start back here. It starts as a degree 4. And what we're really doing here is dividing by x minus 3 when we do the first division, right? So if you have x to the 4 and we're dividing it by x, now this is going to be a cubic, x to the 3rd. And these are the coefficients. So if I actually wrote this out, it would be 1x cubed plus 5x squared plus 8x plus 4, and then the remainder is 0, so I don't need that. You see what I'm saying? Now I'm taking this cubic, and I'm dividing it again by, this would be like dividing by x plus 1. Does that make sense? And when we divide that by x, this x cubed becomes x squared. So I know the first number corresponds to the x squared term. And then this has to be 4x, and that has to be the number 4.
To determine it, like what's going to be out there, it has to look at the first equation?
Yes.
Okay, and it subtracts each.
Exactly. Each time it gets lower and lower. Yes. So if we started with, this is a good point. If let's say we started with a degree 5, we would probably have to do this 3 times in order to get a quadratic that we can just solve by hand.
And it always has to be a quadratic. Right?
Yes, because we don't know how to factor polynomials that are degree 3 or degree 4. Does that make sense? Okay. Anything else? Let's try. Oh, I forgot one thing, you guys. I'm sorry. So we found the roots are the zeros, right? And now it says use the zeros to factor the original polynomial. Okay? So let me just kind of write my answer over here. H of x. Knowing that these are the roots, now we can work backwards and write out the factors like we've been doing in the earlier sections. Does that make sense? 3 is a root, so what factor does that translate to? X minus 3. Negative 1 was a root, so that's x plus 1. Negative 2 is a root, but remember that this had a multiplicity of 2, so that's going to be squared. Okay? So we're using the rational root theorem to find all the roots, and also now we can factor these, degree 4 polynomials that we don't really have a way of factoring. So, yes?
How do you get the square?
This one?
Yeah.
Well, right here.
Oh, then
There's 2 of them, so yeah. Does that make sense? Yes.
When you're doing synthetic
Division, yep.
how you get the negative or the positive in the bottom?
This one?
Yeah.
I'm using the calculator. So, because honestly, I don't want you guys like just going through this list and testing 1, testing 2, testing, you know what I mean? So we're using the calculator to kind of cheat a little bit and see what the zeros are so that we can get it started. And so I saw right away over here that this was a 3, and so that's what determined that I'm dividing it by x minus 3.
Does it matter with zero you?
No, as long as you use 1, yeah.
And then you got, so then how did you get the negative one? You just chose.
I just looked at it again and picked another one, yeah. And the order that you do it in, it won't matter. You're still, in the end, you're still going to get these same 3 roots.
And then why are you not using the original equation to do synthetic division?
That's an excellent question, and that's also a common mistake that people make. If I were to use the original again and divided it with the negative 1 or another root, I would just end up with a different looking cubic. I don't know how to solve cubic equations. You know what I mean? We're really good at quadratics because we can either factor the quadratics or we can use a quadratic formula. We don't know, there is a cubic formula, but it's really complicated and we're not learning it. So our goal is to take whatever degree it is and reduce it to a quadratic, and then now we just use our techniques for quadratics, factoring or quadratic formula.
So it's just a way of breaking it down.
Exactly. Until something that we can handle, exactly. Yes?
So is this what that's like usually how I say? Is that like another way you can find out what we did yesterday?
Yes. Well, it's kind of putting it together. Yeah, it's the same method, it's just taking it one step further from what we did yesterday. Because yesterday we just listed the possible roots, and we just kind of left it at that.
So on the test, are we going to have to list all the roots? Like remember instead of C, for example.
So look, if this were a test question,
Yeah.
I would expect you to have exactly what I have here. Maybe not in this order, you know what I mean? But you would have listed your P's and Q's, you would have told me what the possible roots are, and then you would have tested a root right away that
Yeah.
has a 0 remainder because we're using the calculator to help us.
It's just like
You will, yeah, but I'm not. I don't think I'm going to ask anything that. No, yeah,
It's just like time consuming, you know what I mean?
yeah. Is that a stretch over there? Okay. Yes.
If you start with a different number,
Yes.
or a different zero, will you still get the same?
You'll get the exact same factors and same exact roots. You would have just gotten them in a different order. So maybe in the end, like if you found, let's say you found a 2 root,
Yeah.
and then you found a 1 root, or a negative 1 root, and a negative 2 root, I mean. Then you would have gotten down here, you would have ended up with something that's x minus 3 with another x plus 2. You see what I'm saying? But in the end, you're still going to have the same exact roots. Yes?
So if we go access the calculator, do we need to check the work using?
Yes, we're requiring you to do so because you need to demonstrate that you understand the rational root theorem and the synthetic division process. Just be happy that I'm not having you do this without a calculator because in some classes you would do this without a calculator and you would literally just be testing until you got a couple that worked. Yes?
So for the when you first go down to using a synthetic division, when you for the first one when you're using the original equation for it, is the only way to like use it is to like find it with a calculator? Because like the other ones, like you've seen me like don't have to do it, but like the first one seems you can't use a calculator.
Yes. I mean,
okay. Like
that's
what
the
we're looking
best,
at.
fastest way, yes.
Yeah.
Otherwise, you're just testing.
Yeah.
And yes, there are other theorems that we could learn, like there's a Descartes' rule of signs, lower and upper bound theorem, which will help you narrow down the search. So like looking at this, you might have figured out that maybe that there's no negative roots just by looking at it without a calculator. So then at least you would say, all right, well, I'm not going to waste my time testing -1, negative. I'm just going to start with 1, 2 until I get 1. You know what I mean? But we haven't talked about all that other stuff yet.
You know how we did like the other? Like we had 1440.
Yeah.
So after that, how would we know that that's where we could stop?
Once you get, think about, if we start with degree 4,
Yeah.
we divide once, now it's degree 3. We divide twice, now it's degree 2. As soon as it's degree 2, that's when we stop.
Wait, how did that?
Because this was a degree 4
Oh, so if we were to like
Okay.
add that
into an equation, yeah.
Oh, okay.
You see what I'm saying? That's what Jordy was saying earlier. So if you take this degree 4 and divide it once by that root, now we get a cubic out of that. We divided it by another root, and that cubic becomes now a quadratic.
Oh, so we skipped the 4, and then the first
Yes.
division thing we did, that's 3, and the next thing we did was 2.
Yes.
Oh, okay.
Yes. Yeah, each time you divide it, just reduces it by 1. Okay, excellent questions, you guys. Another one? Okay, yes. All right, let's try one more. I'm not going to do all the examples here, okay, but we are going to, let's do B. Yeah, let's do B. Okay. What are all the p-values?
1 and 2.
Plus or minus 1, plus or minus 2. That's it. Q values.
1 and 2.
Also plus or minus 1, plus or minus 2. So your possible roots, 1, 1/2, 2, and then that's it. Everybody good with that? I know we're like going faster now, but okay. Now, again, I'm not going to have you just start testing. You're going to go ahead and use the calculator. Graph the polynomial 2x to the 4 minus x cubed minus 5x squared plus 2x plus 2. And again, let's just start with the standard screen and hope that we see what we need to see. Looks pretty decent. Okay. Well, this one looks like a... Did I type something in wrong? No, looks good. Okay.
Because they're gonna
the imaginary number because it only shows the eight?
Well, let's see. You want to zoom in a little bit? Let's zoom in. Oh, sorry. Yeah. Okay. So now look. Let's see what's going on here. There looks like we have some fractions, right? Because we're between -1 and -2. But look, the only fraction I have is -1/2 or +1/2. So that's probably this one right here, right? Because that's 0 and this is -1 over here. So that means that this one over here it's not phony. It probably means that it's a radical or something that we'd have to use square roots with, like with the quadratic formula. It's not on this list. Does that make sense? So let's go ahead and look at this first one right here on the left side. Let's hope that it's -1/2. Looks good. Okay, you guys with me so far? -1/2 seems to be a legit root, so let's go ahead and divide. -1/2. Write down the coefficients, 2, -1, -5, 2, and 2. Bring down the 2. Multiply. You get -1. Add them up. -2. Multiply again. That's +1. Add that up. -4. Multiply. You get 2. Add it up. You get 4. This is now -2, and it better be 0, otherwise we're doing something wrong, right? So now, what is this over here? What degree is this now? This is cubic now. Does that make sense? Let's go ahead and just put another little number here outside. Is that the other one over here?
Yeah.
Nicole's already confirmed that it does work. I'm going to go ahead and trust her. You guys okay with that? Okay. 1 works. And now we're going to divide one more time, but only using these values here. Bring down the 2. Multiply. Add. Multiply. Add. Multiply. And again, we should get a 0 remainder each time, right? Okay. So now we've established so far that our roots are -1/2. We just confirmed that 1 works. What does this translate to now? 2x squared minus 4. There's no x term because it's a 0 in the middle. Does that make sense? And now you can either factor that or solve. We can solve by getting x alone for that one, right? Just add 4, divide by 2, and square root it. And we get, very good, plus or minus the square root of 2. Okay, so our roots are those 4 right there. Make sense? And now the second part of the question was to use the zeros to factor. Okay, so now here's where we're going to be really careful. This was f of x. So f of x. What is the leading, bless you, what's the leading coefficient here?
2.
The leading coefficient is a 2. That means that I'm going to have a 2 factored out when I write out all the factors. Whatever that leading number is, you're going to put it there. Because now you're going to use these roots or these zeros to build all the other factors. Does that make sense? -1/2 translates to x plus 1/2. 1 becomes x minus 1. And then we're going to have x minus root 2. And I'm out of space here. What's the other factor? X plus root 2. So those would be the factors right there. And those are the zeros. Okay?
Wouldn't it simplify it?
No, we're just going to leave it like that. This is the linear factors format. Okay? All right. One more example. I'm not going to go through it, though. I'm going to let you guys try it. Go to example 5 and go ahead and try that one on this page over here. So take a few minutes and work through that.